All right, so one final example using approximation of a tangent line, or otherwise known as linear approximation. The idea here is that if you have an f of x plus h that is tough to compute, here's your x plus h, but you have an f of x that's easy to compute, and an f prime of x is easy to compute, you could just move along the tangent line using these easy to compute things to get you the function value off the tangent line, which, while not equal to the function value off the original function, is close enough that might be good enough. And frankly, if you're trying to do something really nasty, like look at this, like let's try to estimate the value of square root 16.01. In the last video, we were cubing 2.02, and you might have even thought, well, yo, Dr. Y, like 2.02 times 2.02 times 2.02, I could have ran through that faster than we ran through the problem. Maybe so. But what about this guy? How are you going to find the number that multiplies by itself to be 16.01? That's tricky. That's really sensitive computation. I don't want to mess with computing that. Now, of course, a calculator can produce this value, but the long story short is let's try to use the tangent line to get ourselves an estimate without having to even use a calculator. Okay, so what are we dealing with here? We're dealing with the square root. So let's consider the function y equals square root x. Let's consider the square root function, and where are we going to look? Because here we've got our point that's nasty to compute at 16.01, but that's actually quite near a point that's easy to compute, 16. So let's look at x equals 16 and go through the computation. So how are we going to do this? First, let's compute f of 16. The function value at 16. Square root 16, 4. No sweat. Let's consider the derivative value at 16. Well, to do this, we're going to have to take the derivative of the square root function, which the derivative of the square root function, as you know, is 1/2 x to the minus 1/2, because of course you could take the square root and look at it as x to the 1/2 power. Bring the 1/2 down, reduce the 1/2 by 1, which could also be viewed as, for simple computational purposes, let's just look at it as 1/2 square root x, because x to the minus 1/2 is a power of minus 1/2 in the denominator, which means a square root in the denominator, which is precisely this 1/2 square root x. So f prime of 16 is going to be 1/2 square root 16. Which is going to be 1/2 times 4, which is going to be 1/8. Okay, so we've got our original function at 16, our derivative at 16. Let us also find our h. Our h is the difference along our x-axis, the difference between the value that we're looking to plug in and the value that we can easily plug in. So this is 16.01 minus 16. 0.01. If I could just make a note here, what if we wanted to do 15.99 or 15.9 or something to the left of 16? Whereas the change in x here is positive and we're moving to the right, if we were looking at 15.9, the h would be negative. Okay, but the long story short is, once you've got the function value, once you've got the derivative, once you've got the h, we just use the formula to get the f of x plus h that we're after. So f of 16.01 is not exactly equal to, but approximately equal to our original function value 4, plus the change in y, which is the slope times the change in x, which is 1/8 times 0.01. Oh man, I guess that's actually going to be kind of ugly to compute, unfortunately, but it's not going to be too bad, because 1/8 is 0.125. I tell you what, I'll write it out over here. 4 plus 0.125 times 0.01, and whenever you multiply by 0.01, you hop the decimal place 2 to the left, so this is going to be 4.00125 from hopping the decimal place twice, multiplying by 100th. So that's going to be 4.00125. Cool. Okay, so we worked through the numbers. It wasn't even clean down below, but so be it. The long story short is we ran through the computation and we got to a point where we at least got an estimate for the square root of 16.01. It was a little bit perspiration inducing, but it would have been easier than guessing and checking values that would multiply to be 16.01 square rooted. And I tell you what, let me look at my calculator here to get us, how do I clear this thing? Okay, there we go. Let's take the square root of 16.01. The square root of 16.01 by calculator is 4.00124980474 blah blah blah. I tell you what, we got pretty damn close, didn't we? I mean, it wasn't exactly 4.00124980474, but heck, it was like mighty close. And the computation was a lot easier than trying to guess and check and guess and check and guess and check. So, if you have a function value that you're trying to compute that's nasty, but you can move a little bit along the x-axis to get to a function value that's easier to compute, compute the easier to compute function value. Compute the derivative at that point. So now you have the slope of the tangent line. And then move along that tangent line, however many units you need to move along the x. If you're moving to the right, this is going to be a positive h. If you're moving to the left, this is going to be a negative h. And then the long story short is you take the original function value plus the change in y, which is the slope times the change in x, and you get out something that is mighty close to the actual value. And in some sense, this is a victory of computation because this is something that you could do on a desert island, whereas this guy is something that would be almost impossible to do in such a circumstance.